Welcome to TSAT. Today I am going to discuss a topic in geography known as the composition and structure of the atmosphere. So, in this context, we are living under the ocean of air above the earth. So, here this atmosphere which contains different gases is on the surface of the earth because of the gravitational force. So, because of the gravitational force, the atmosphere is above the earth. So, here it consists of different gases, and the variation or the percentage of these gases vary from gas to gas, which have got a lot of impact on weather and climate, where the basic fundamental difference between weather and climate is, in the case of weather, it studies about the atmospheric phenomena within or less than 72 hours of duration, whereas climate also studies the phenomena happening in the atmosphere, but it studies the phenomena happening in the atmosphere over a long duration, over a period of a decade or so. So, that is the fundamental difference between weather and climate, the conditions varying in terms of temperature, precipitation, etc., and the composition of the air in terms of different gases constitutes the content of weather and climatic phenomena. So, here in this context, to know about the composition of air, we shall discuss that before discussing about the composition of air, we need to know the importance of atmosphere. The reason behind it is atmosphere contains certain gases. Some of the gases in the atmosphere are considered as greenhouse gases. In this era, because of the greenhouse impact, greenhouse gases are considered to be very dangerous, but it is not true. Greenhouse gases are essential in the atmosphere because the existing temperature conditions essential need to be maintained. The greenhouse gases in the atmosphere are very much essential. The reason behind it is the existing average temperature of the earth is because of greenhouse gases. So, these greenhouse gases trap the terrestrial radiation. So, what do you mean by terrestrial radiation here? Terrestrial radiation is, for example, the insulating solar radiation into the Earth's atmosphere strike the surface of the earth. In this context, the light energy is being converted into heat energy after striking different topographical features of the earth. So, the light energy here is being converted into heat energy. This heat energy is being radiated back into the space. So, in this process of radiation, because it has been transformed into a different form of energy, that is from light energy to heat energy, this heat energy is also being described as infrared waves, which are being reflected back into the space. So, in the process of being reflected back from the surface of the earth, these greenhouse gases obstruct and absorb this terrestrial radiation. So, the heat energy or the infrared rays which are being reflecting back to the space from the surface of the earth is known as terrestrial radiation. The incoming solar radiation and the terrestrial outgoing heat energy must be balanced to maintain a constant average temperature of the earth. So, here these greenhouse gases trap the terrestrial radiation. Because of these greenhouse gases trapping the terrestrial radiation, the existing range of temperature which we are experiencing, which is comfortable for the survival of the life, is possible because of greenhouse gases. But if the greenhouse gases which are responsible for greenhouse impact because of the anthropogenic release of greenhouse gases like carbon dioxide, methane or water vapor or chlorofluorocarbons, which are more than the natural, trap the terrestrial radiation more than the essential and increases the average temperature of the earth, is causing greenhouse impact. But greenhouse gases are very much essential for maintaining the average temperature of the earth required for the survival of life, both flora and fauna in the environment. That is the importance of greenhouse gases. And carbon dioxide is very much essential, because without carbon dioxide, there is no possibility of photosynthesis. Without photosynthesis, there is no possibility of food material being prepared by the plants. So, such is the importance of greenhouse gases. So, because the greenhouse gases are trapping the terrestrial radiation, the average temperature of the earth right now being projected to you, the 15 degrees Celsius, is being maintained because of greenhouse gases. In the absence of greenhouse gases, the average temperature of the earth would be minus 18 degrees Celsius. So, at this temperature of average minus 18 degrees Celsius, the existing type of living beings cannot survive. So, in the absence of greenhouse gases, the approximate average temperature is 35 degrees more it would be. So, here what is happening here is the average temperature, the difference between minus 18 degrees Celsius plus 15 plus degrees Celsius, the range is approximately around 35 degrees variation, is the variation in the absence of greenhouse gases. These aspects which you need to keep in mind. Questions can be asked in these ways. What is the average temperature of the earth? It varies from 14 degrees to 15 degrees. Depending upon the answer, you need to give an answer. Because of the global warming phenomena, it has risen to an extent from 14 to 15 in between. There might be a question, in the absence of greenhouse gases, what would have been the average temperature of the earth? Might be a question. Then it is minus 18 degrees Celsius. After knowing this, as far as the composition of the earth's atmosphere is considered, it is made up of different kinds of gases like the nitrogen, oxygen, argon, carbon dioxide, helium, hydrogen, ozone, etc. So, these are present in these percentages. Out of all these gases, nitrogen is predominantly present. 78% of the air contains nitrogen. Oxygen contains 21%, argon 0.93%, carbon dioxide consists of 0.03%, and the rest contains less than the 3%. Here, in this context, in the predominantly 78% of nitrogen which is present is very much important, because it is essential for the plants in terms of protein preparation, without which protein cannot be prepared by plants, and we are made up of proteins. A protein source is from one of the element in protein is nitrogen. So, here through some microorganism conservation, fixation of atmospheric nitrogen, the plants are being made aware regarding this nitrogen. So, that is the importance of nitrogen in the atmosphere. And in terms of oxygen, oxygen is essential for respiration in living beings, both in the case of plants and animals, without which energy cannot be assimilated in the process of respiration. And argon is a predominant inert gas in the atmosphere. And carbon dioxide, even though it is very less, as I have already specified, the impact in terms of environmental phenomena or for the life forms, it is very much important, because we contain carbon in our body, with which we are constructed. Photosynthesis cannot happen in the absence of carbon dioxide. So, these are the different important aspects of these gases present in the environment. Apart from these gases, water vapor is present in the atmosphere, dust particles are present in the atmosphere, smoke, salt and other impurities are present in the atmosphere. So, the water vapor which is present in the atmosphere is because of evaporation from the water bodies, because of solar insolation, and because of a phenomena through plants known as the transpiration. So, through the pores of the plant leaves known as stomata, the water vapor evaporates into the atmosphere, and because of the heat from the oceans and other water bodies, water evaporates into the air. This water vapor in the air is not the same throughout the latitudes. It varies from 4% to 1%. It is maximum at the tropical regions and a minimum at the deserts and polar regions. So, at maximum it extends up to 4% volume and minimum to 1%. And water vapor plays a very important role in the weather and climatic phenomena. The reason behind it is this water vapor, it carries certain amount of energy into the atmosphere. It carries certain amount of energy into the atmosphere, because in this process, what happens is, when the water vapor is evaporating in terms of change of state from liquid to vapor, it requires certain amount of energy. In this process, the heat energy absorbed by the water bodies in the ocean and other water bodies is absorbed by the water molecule and gets into the atmosphere. In this process, for the change of state from liquid to vapor, it requires energy, because of which this heat is being carried into the atmosphere, because of which the temperature conditions vary in the environment. So, apart from the terrestrial radiation, which is responsible for the temperature conditions in the atmosphere, the energy carried by the water vapor is also responsible for the temperature conditions in the atmosphere, which is responsible for precipitation, which is responsible for low pressure conditions and high pressure conditions, leading to change in the weather and climatic phenomena. So, water vapor plays a very major role in climatic and weather phenomena in terms of precipitation and temperature conditions. Dust particles. Dust particles also play a very major role here. The dust particles are not the amount of dust particles present in the atmosphere is not the same throughout the atmosphere. For example, in the equatorial region and in the polar regions, the dust particles are less. In the tropics and temperate regions, the dust particles are more. So, these dust particles act as an hygroscopic nuclei. So, what do you mean by hygroscopic nuclei here is, hygroscopic nuclei means, hygro means water. So, these dust particles act as an obstructing particles for the evaporating water vapor, and this water vapor sticks around the dust particle, accelerating the rate of condensation. So, for example, when you obstruct the boiling water vapor with the help of a plate on a stove, for example, when the water is boiling on a stove, take a cool plate and obstruct the evaporating water, what happens is the water vapor turns into liquid droplets. In the same way, the dust particles which are floating in the air, obstructing the evaporating water, are responsible for the change of state of vapor to liquid, which is known as condensation. So, the rate of condensation is accelerated with the availability of dust particles in the cloud, which helps in precipitation. That is the reason why dust particles acts as hygroscopic nuclei. So, here in this case, which has been projected to you, the amount of water vapor decreases from the equator towards the poles. So, from the equator towards the poles, what happens is the water vapor gradually decreases. The reason behind it is the amount of temperature available when you move from equator to the poles gradually decreases. The more the temperature, the more the rate of evaporation. So, here in this context, what happens is the angle of incidence at the equator is 90 degrees. So, when we are moving towards the polar regions, what is happening is the angle of incidence is gradually reducing. Means the same rays need to spread across a larger area because of the geoidal nature of the earth, because the earth is a curved structure, curved feature, because of which from the equator to the poles, the same rays have to spread over a larger area. Because the energy is being distributed over a larger area, the amount of energy received per square meter or per square centimeter gradually decreases from the equator towards the poles. That is the reason why the temperature gradually decreases from equator towards the poles. So, because the rate of evaporation is proportional to temperature, when the temperature decreases, the rate of evaporation decreases. That is how the amount of water vapor is varying across the latitudes from the equator to the poles. So, water is the only substance which can exist in all three states on the existing conditions on the surface of the earth in solid, liquids and gases. So, the points which I have projected can be converted into an objective bits. So, for example, water vapor in the atmosphere gradually decreases from equator to the poles. It can be an objective bit. So, water is the only material or a substance which can exist in three states, that is solid, liquid and gas, can also be a bit. And this water vapor is so important because the water vapor has got a latent heat. So, what do you mean by latent heat here? So, latent heat is a condition where which latent means hidden, which cannot be perceived, which cannot be measured. That is the meaning of the word latent. So, for example, latent heat is, for example, when the water is boiling, after reaching 100 degrees Celsius for pure water, you cannot raise the temperature of water more than 100 degrees Celsius because the boiling point of water is 100 degrees Celsius. Then what is happening to the amount of energy which you have supplied to heat the water? Previously, when you are heating water, the water at room temperature at 27 degrees Celsius has increased to 100 degrees Celsius. But after 100 degrees Celsius, what is happening to the calories of heat energy which you have supplied? The energy which cannot be measured on the thermometer is being used to change of state from liquid to vapor. So, these calories of energy being observed which cannot be measured in the thermometer is known as latent heat, which is being carried into the environment. So, in this process, what happens is, there is another condition. This condition which I have explained to you, the energy being consumed for the change of state is known as latent heat of vaporization. So, another condition known as latent heat of condensation. In this process, the energy is being released out into the environment when the vapor is being condensed back into liquid. In this process, the energy when it is being released into the atmosphere further decreases the density of the atmosphere because of increasing in the temperature. The increasing in the temperature decreases the density of the air. So, the latent heat is responsible for this. So, because of the decreasing in the density of atmosphere, what happens is the atmospheric pressure decreases, because the atmospheric pressure is the manifestation of gravitational field on the air. When the gravity pulls the air, leads to pressure. So, lesser density, lesser mass, lesser weight, lesser pressure. Consequently, the opposite is the same. The more denser, more weight, more pressure and more atmospheric pressure. So latent heat is also impacting the atmospheric pressure, because of which the directional flow of wind changes from place to place. Always wind flows from high pressure to low pressure. Low temperature condition creates high pressure, and high temperature condition creates low pressure because of low density. So, that is how the weather and climatic conditions are being impacted by the latent heat of vapor. So, the next point is tropics and temperate regions have more dust particles, which I have discussed with you, and these dust particles create optical phenomena, red and orange hues. So, in the atmosphere, because of during the sunrise sometimes or the sunset, the change in the colors, one of the reasons is the dust particles. The other gases with carbon dioxide. So, you have got greenhouse gases which are natural and anthropogenic. For example, chlorofluorocarbon is a greenhouse gas which is a man-made gas into the environment. The rest of the gases are generated both because of man-made causes and natural causes, like the carbon dioxide, water vapor, methane and chlorofluorocarbons are considered as greenhouse gases. Apart from that, the atmosphere has got ozone extending between 10 to 50 kilometers. The importance of ozone is the ozone filters the incoming ultraviolet radiation, decreasing the intensity of UV radiation on the living beings. That is the importance of ozone layer. Argon is the most predominant inert gas in the atmosphere. They may ask you, out of all the different kinds of inert gases in the atmosphere, which is the predominant gas present? Argon. Other inert gases are neon, helium, krypton and xenon are the different inert gases. An inert gas is one which doesn't react easily. That is what an inert gas is. Next concept is the structure of the atmosphere. The atmosphere is a concentric layers of air above the earth, and these layers of the earth's atmosphere are not homogeneous. The density of the air gradually decreases with increasing in the altitude. That is what been given. This can be asked, how with the altitude the density of air varies, can be a question. Next is lapse rate. Lapse rate is the decreasing in the temperature with the increasing in the altitude. The reason for the decreasing in the temperature is, as I have already discussed with you, what is meant by terrestrial radiation. The main source of heat to the atmosphere is terrestrial radiation rather than solar insolation. So, when we are moving away from the heat source, the temperature gradually decreases, which is been described as lapse rate. So, what is meant by lapse rate can be a question. What is the rate of decreasing in the temperature with the increasing in the altitude can be a question. So, for 165 meters of ascent, there will be 1 degree decreasing in the temperature, or for every kilometer there will be a decrease in 6 degrees Celsius, can be a question being asked in the examination. So, 90% of the water vapor in the atmosphere exists in troposphere. So, the troposphere is the first layer of the atmosphere, can be a question. So, these are the different layers of the atmosphere. The first layer is known as the troposphere. The second layer is known as the stratosphere. The third layer is known as the mesosphere, ionosphere and exosphere. So, here in terms of the composition, in terms of the density, the layers of the atmosphere vary. In terms of the temperature, so the first layer is the troposphere, is the first layer. In this troposphere, as I have discussed regarding the different kinds of gases and their percentages and their significance, predominantly happens in this layer. The altitude of the troposphere is not the same throughout the surface of the earth, from the equator to the poles. So, the altitude of the troposphere, the boundary between troposphere and stratosphere is known as tropopause. A tropopause is a transitional zone. So, here in this context, the altitude of the troposphere is 18 kilometers at the equator and 8 kilometers at the poles. The reason behind it is the air expands more at the equator. As I have shown to you, the incident angle of solar radiation is 90 degrees. What happens is the amount of heat is more, the expansion of air is more, the rise of air is more, because of which the altitude of troposphere is 18 kilometers at the equator and it gradually decreases towards the poles, because the lapse rate, as I have discussed, with increasing in the altitude the temperature decreases. Because the altitude is more, we have got minus 80 degrees Celsius at the equator at the tropopause and minus 45 degrees at the pole. So, in an examination, a question can be asked to confuse you, that you may think that at tropopause in the poles the temperature might be low. No, the temperature is low at the equator at the tropopause. So, that is a kind of anomaly here you can observe, where you can be misled here. The next layer is stratosphere. The second layer, in the case of stratosphere, a layer known as ozone gas is present here, which is responsible for filtering the ultraviolet radiation, which extends up to 50 kilometers. So, at the stratopause, the boundary between mesosphere and stratosphere is known as stratopause. The temperature is 0 degrees Celsius here. at a 50 kilometers altitude. The mesosphere, the third layer, extends up to 80 kilometers and has minus 100 degrees Celsius at the end of the mesosphere. So here next is the ionosphere. The ionosphere, it is being described as ionosphere because it contains ions. Because the charged elements are considered as ions, that is the reason why this is known as ionosphere. And here in this case of this ionosphere, which can be used for radio communication because it reflects radio waves. And the exosphere above 400 kilometers, where the temperature reaches to 1000 degrees Celsius, and this merges with the outer space. So the temperature variation happens in this way in these different layers. They may ask you a question, how the temperature varies across this layer. So in the troposphere, it gradually decreases. Till the ozone layer, the temperature is constant. In the stratosphere, after crossing ozone layer, the temperature again increases because the ozone layer traps the UV radiation, because of which the temperature increases in the stratosphere. Again in the mesosphere, the temperature decreases. In the mesosphere, in the thermosphere or the ionosphere, gradually again the temperature increases. This is how the temperature variation happens in different layers of the Earth's atmosphere. The density variation happens and the atmospheric pressure variation happens. Density gradually decreases with the altitude. Atmospheric pressure also decreases with the altitude with these different variations. So this is how the variations happen. So these are the different layers of the Earth's atmosphere and their variation. So here, insolation and temperature, 2 calories per square centimeter is the amount of energy being consumed or absorbed by the surface of the Earth. Only 50% of the energy reaches the Earth's surface. So because of a phenomenon known as albedo, the energy is being reflected back into the space, because of which only 50% of the energy is being received by the Earth. So the reflecting nature of different surfaces of the Earth is known as albedo. Heating and cooling of the atmosphere is done by 3 processes: radiation, conduction and convection. So in this process of transmission of energy by these 3 processes, they are different here. For example, the energy from the sun reaches the Earth through a process of radiation. Radiation doesn't require a medium to transfer. So for example, the light energy is being transmitted or radiated from the sun because light contains photons and this doesn't require any medium to transfer. But in the case of conduction and convection requires medium. The difference between conduction and convection is, in the case of conduction, there is no movement of mass. For example, when the rock is being heated or any material is being heated, what happens is, in a solid state, matter, when it is heated, the energy is being transmitted to atom in the solid, but not with the movement of matter. But in the case of convection, which happens in fluids, where fluid is both gases and liquids are considered as fluids. In the case of fluids, what happens is there is possibility of movement of matter. So for example, in the case of the movement of air is a fluid. When the surface of the Earth is being heated because of terrestrial radiation, the layer near the Earth gets heated, decreases its density and rises above because of the decrease in the weight. So it is a process of convection. In this process, it carries the heat energy from place to place. So these are the 3 different variant modes of transmission of heat. This is how, for example, in the primary circulation, because the equator is being heated, the air rises above at 𝗖𝗍, responsible for a convection of energy. The factors which control the temperature are the land and water nature, prevailing winds, ocean currents and altitude. So the land and water nature is, for example, here the land can be heated very fast and it radiates the heat very fast to the atmosphere back, but that is not the case with water. Water consumes more amount of time to get heated and to release heat back. it takes more amount of time. In this process, it retains more amount of heat energy for a longer duration, because of which it impacts the temperature of the atmosphere above. So, to understand weather and climatic phenomena, we need to understand the temperature conditions varying in the oceans. Then only we can perfectly understand the weather and climatic phenomena. For example, when the wind is blowing from ocean to land and land to ocean, because of the difference in the nature of heating, we get a cool breeze from ocean during day, but during night we may get a warm breeze, because the oceans doesn't cool during night, as the continent rocky nature cools very fast. Because of this nature, the temperature conditions of a region is being impacted. The other factor is prevailing wind. So, in the prevailing wind means the directional flow of wind. For example, take the case of this primary circulation. So, when the wind is moving from tropics to equator, in this process what happens is the wind can blow from a continent to ocean or ocean to continent. Because of this reason, depending upon the temperature of the ocean waters, a ocean water might be cold current or a warm current. So, depending upon the warm and cold current conditions and the prevailing wind, if a wind is blowing from a warm region of the ocean, we receive warm air. If the wind is blowing from the cold current of a region, we receive cold air, so, or cool air. So, the conditions which are prevailing regarding the temperature or land and water nature, the direction of flow of wind, ocean currents, whether they are cold or warm, and altitude, as I have discussed with you in terms of lapse rate, in terms of terrestrial radiation. So, these are the different factors which are responsible for impacting the temperature of a region. Okay friends, let us meet in the next session discussing another topic in geography. Thank you.